So I'm going to share my screen so that we can be able to try out some programs. Okay, I'm going to do one program using a for loop so that we can be able to see the difference between break and continue statements. I'm going to share my entire screen. Hope the screen is visible to everyone. So I'm going to open up a Dev C++, my favorite editor or compiler, and then I'm going to create a new file. I'm going to create a new, click on new source file. Then I'm going to save this file first. I'm going to click on file, save as. And then I can save it in a document, C programs. Then I'm going to call it loops.c. Going to save that. Then as usual, I'm going to start with a comment to tell us what this program is about. The program to demonstrate how loops work. Then I'm going to start with a preprocessor command. I'll include the standard input and output file, stdio.h. Then I'll have my main function. Just hope it's feasible enough. I'm going to try and zoom this one a little bit so that we can all be able to see how to see clearly. I hope now it's visible enough to everyone. So then I'm going to create one variable, our loop control variable. I'm going to call it int n. Then down here I'll have a for n is equals to 0, semicolon, n is less or equal to 10, another semicolon, then n increments. Okay. Then inside here, I want this loop to print out number 0 to 10. So I'll have printf. Then I'll have my my control string here. I'll have a %d. Then I'll also have an escape sequence for a new line. And then I'll output n. Then I'll have a semicolon here. So that's a simple for loop. Okay. It will print 10, 11. It will actually print the first 11 numbers, first 11 natural numbers from 0 all the way to 10. Okay. Yeah, and you can see I've been able to achieve that by only writing code 3 lines long. Okay. So now I'm going to compile this program. So to compile this program, I'll execute and click on compile. Okay, then I can scroll down. You can see there is a problem here. I misspelled my include. Now it's good. Come back here and compile again. Now there is no error. It tells me no errors, 0 warnings. Then I can go back to execute and click on run. run my program, and you'll see that it has outputted digits 0, 1, 2, 3, 4, 5, 6, 7, all the way to 10. Okay, I can close that. Now you can see that my loop has been able to output numbers from to print number 5. I just wanted to print all the way to number 4, then it will skip number 5, then it will go to number 6. How can I achieve that? I can include an if statement here. I'll have if n is equals to 5, continue. But no, for that to work, for us to be able to see the difference here, we'll have to put the output statement just below my if statement. I'm going to put it there. Okay. So in this case, I've used the continue statement. Okay, so this continue statement will only execute when n is equals to 5. Okay, and now I want us to see what will be the difference in our output. So I'm going to go back here. I'll click on execute. Then I can use the shortcut compile and run. Okay, and you'll be able to see here it has printed 0, 1, 2, 3, 4. Then it skipped 5 and went to 6. Okay, so now I think from there, from that example, you can be able to deduce what continue statement is used for. Okay, continue is just a single word terminated by a semicolon. Okay. So what that does is continue, it skips all the other lines remaining, in the loop and goes to the next iteration. Okay, so that means when n is 5, it will skip this printf statement and go now to the next iteration where n will be equals to 6. Hope we are together. Are we together on that? Then now I also want us to look at now how the break statement now is different from continue. So in this case, you can see that my loop initially, it was supposed to print the values 0 to 10. But if I wanted it to print only up to 5, if I wanted it to print only up to 5 or up to 4, how would I put it? So in that case, I'm going to use, instead of continue here, I'm going to put break. Okay. So that means what the break statement does, it exits or it terminates the loop prematurely. It terminates the loop prematurely. So that means we expected the loop to run 11 times, but in this case, it's going to run only 6 times. Okay, I think I can compile my program and we'll see what the output will be. Compile and run, and you can see it only prints 0 all the way to 4, and it adds there instead of going all the way to 10. Hope we are together. Then now we can try something else. Okay. Another statement is go to. Okay, And this is how GoTo works. For GoTo to work in your program, you must have your program must have something we call labels. Okay? Your program must have something we call labels. I think I'm going to show that labels, they start with they are only they contain letter followed by a full colon. Okay? And they label a certain section of your program. For example, let's say I had a menu here. Let's say I had a menu here. Let's say call it main. I have a label like main. And then I'll have printf. Let me try to mimic the menu like that one of M-Pesa. So that's my main menu. Okay. Let's say inside now M-Pesa. Let's say inside the M-Pesa, we have now the M-Pesa menu. I can label it M-Pesa here. So inside the M-Pesa, we'll have we have it this way. Let's say inside M-Pesa, we have three menu. 1, 2, 3. And then here, the first one will have one is send money. And 2 is withdraw. And 3 is buy airtime. Then I can have another menu here and call it surf. The printf one is my account. And 2 is services, products and services. Okay, so I have those two menus now. I want to help the user navigate in my menu. So I can have here an if. I'm going to add, I can still use n. I can have a printf. Enter your choice. Let's say we have it like that. And then here I'll have scanf, %d. And then I'll use the variable n to store the user's choice. Then now I'll have if n equals to 1, I'll have go to M-Pesa. Else, if n is equals to 2, go to SAF, go to SAF. Else, I'll output have a printf invalid. Invalid choice. Then I'll have go to main, so that it takes you back to our main menu. So now I've been able to create a simple menu there. Okay. Yeah, so now if I was to run this program, I'm going to remove this part. Okay. Now I want to run this program and see how it works. Okay. Go to execute, compile and run. Okay. It will bring me my menu here. Let's say, for example, I choose 1. Okay. You see, it will bring me the menu for Safaricom. Okay. Let me just close this. I'll run again. Let's say I enter a value like 3. They tell me invalid and bring up the M-Pesa menu again. I think I can add a new line there so that it looks presentable. And go to execute, compile and run. So now I enter a choice like 3 and click enter. Since it's not one of my choices, it will write invalid choice and then it will bring me the menu again. If I enter 4, invalid, it will bring me the menu again. If I enter 5, invalid, and it will bring me the menu again. If I enter 2, it will bring the menu for Safaricom. Okay, so that's how GoTo works. But in this case, we don't encourage using GoTo. Try to avoid it as much as possible. Okay, so the only time you'll need to use a GoTo is when you have a very many nested loops, highly nested loops. That's when you can make use of GoTo. But using GoTo in the way I've used here, it's only for demonstration purposes, but for practical purposes, it's not encouraged. Why? As you can see here, if I, for example, I was to, let me just run my program again. If I was to keep choosing 3, that means this program will never end because it doesn't have a condition. Okay, so that's why the problem we go to, and they don't have a predictable logic. Okay, because there is no way this loop will end. They'll keep going to round and round, and then you can also get lost in your own code. Okay, you can end up creating a code that we call a spaghetti code, and we don't want you to do that. So at this moment, you can try to avoid GoTo as much as possible. And with a question on those 3 statements, that is a break, continue, and GoTo. Anyone with a problem with that? Anyone with a question? On the 3 statements that we have looked at: break, continue, and GoTo. So maybe I can ask a question. I can ask, let me see, who is in the first guy in my list is Joseph. Okay. So Joseph, what's the difference between break and continue? Joseph, I hope you can hear me. What is the difference between break and continue? Joseph Kimunya, what's the difference between break and continue?
Yes, for
Yes?
break, I hope you can hear me.
Uh-huh.
For break,
Yeah, I can hear you clearly. Yes.
Okay. For break, you
Yes.
have the when running when you compile and run it, it indicates
Yes.
it only bring options to where you have put your limit. Like for example, when you are running your code, it only indicated from 1 to 4. But when you choose continue, it's only compile the whole instruction from 1 to 10. Yeah, so the break
what's the
puts
purpose?
there is
What's the
a
purpose?
limit.
Yes.
I'm saying for break there is a limit. Yeah, so you cannot execute the whole process or the whole program.
So how does the break help us? What does break help us with?
So it helps us not to to cut short the program or to be specific on what you want it to compile and run.
I get you there.
But I'm saying,
Yes.
sorry, it helps you to be specific on what you want to compile and run.
Where do we specifically use it? Where do we find the use for a break? Can we use break with an if statement?
When you don't want to, with an if statement, no.
Yeah. Can we use it where there is no loop?
Can you use it when?
When there is no loop, when there isn't any loop?
No.
So on which types of loops do you use a break?
Else if.
Else if is not a loop, Joseph.
Or else.
Yeah.
No, I'm saying when you use else. So when you use a for loop, yeah, you
or when you're
can.
using
When you are using a for loop, you can be able to use a break.
Okay. Thank you, Joseph. That's a very nice response. Maybe we can have someone else to comment on the same. We can have Ahmed. Ahmed, what do you think is the difference between continue and under which situation do you use the continue? What is the purpose of continue statement? Ahmed. Ahmed, are you there? How about Weston? Weston, can you? Ahmed, you're there? Weston, how about Weston? Tell us the purpose of continue. So for break, just to insist, break is used to exit a loop. Okay, it's used to prematurely terminate a loop. Break is used to terminate a loop prematurely. So then Weston, you can tell us what is the use of continue. Weston or Ahmed? Ahmed, I can see your microphone is on. Can respond. Ahmed, are you with us? How about Kevin? Kevin Murioki.
Yeah, is the question.
The question was, what is the purpose of continue statement?
It is used to continue the loop. For example, if you had exited, you take.
Kevin, you're breaking.
I'm saying
Yes.
the continue is used to continue a route.
How? I can't hear you, Kevin.
I'm saying
Yes.
that you need
I think there is a problem with your internet. There's a problem with your internet. You're not consistent. Can't get you.
Now, can you get me clear?
Now I can hear you.
I'm saying if
Yes.
you using the break, you can continue it using the continue statement.
Okay, thank you. Thank you for that, Kevin. But just to correct you, Kevin,
Yeah.
break and continue, they are not used together.
Okay.
Yeah, so what break does,
Yeah.
it exits a loop. But continue
Yes.
Continue skips to the next iteration. Skips to the next iteration. Yeah. Hope we are together then.
Yeah, we are together.
I think we can continue now. That's all about the loops. So that's all about the loops. Okay. So now I want us to introduce functions. Okay. I want us to introduce functions and see what functions are. But before I go to functions, there is an assignment I have shared on topic 6 on control structures. There is assignment I have shared. So I'll give you some time after this to try and work on it. Okay. I will check it on the course page under topic 6. There is an assignment. So I want us to introduce functions. Okay? And to start with, I want to let you know that functions is one of the qualities that make structured programming very important. Okay, and what structured programming were the strengths are is that you can be able to break down your program into parts, into independent parts. Okay, and those independent parts are what you are calling functions, or it's that concept that we call divide and conquer. The concept we call divide and conquer. For example, you can have a very huge program, okay, for a library management system. Okay, instead of having it all under our main function, we can break it down into maybe 5 functions. For example, we can start with the first function being a member registration. Okay, we can have another one for book lending. We can have another one for book recovery. Okay, so that means after we have divided our program, then we will handle one at a time. Okay, so that means I have 6 enemies. Instead of facing them all at once, I can face them one after the other. Okay, so after I have divided my library management system into 5 functions, I will start with the first function. How do I register members? And at that point, since my program is smaller, it will be easy for me to work on it. It will be easy for me to work on it. Okay, so that means I'll work on registration and make sure it's perfect. Then I'll put it aside. I'll go to the second one, book lending. I'll work on it and make sure that it's perfect. Since it's a small one, it's easier for me to concentrate on it. Okay, I'll work on it and put it aside. Okay, after now I have worked on all the functions, I'll come again and combine them together now to form my program, or to form what we call a system. Okay, so now how will those functions interact, and what will make it a system? The way those functions interact is by calling each other. Okay, for example, inside my main function, anytime I want to register a member, the only thing I'll need to do is to call the registration function. Anytime I want to lend a book, the only thing I'll need to do is to call lending function. Anytime I want to recover a book, I just need to call the recovery functions. Okay, and that one makes your program more organized, easy to upgrade, and very easy to remove errors. Okay, so now from our notes, we are defining a function as a group of statements that together perform a task. Okay, and every C program has at least one function which is called main. Okay, and so far we have been working with only that one function. Then here we are indicating that you can be able to divide your code into separate functions. Okay, but now how you divide them depends on you. But you must make sure that those functions are logically divided. That means one function should only perform a specific task. Okay, yeah. So a function declaration, we have something we call a function declaration, the same way we had a variable declaration. And a function declaration tells the compiler about a function name, return type, and parameters. Then a function definition provides the actual body of the function. Okay, so the declaration mentions 3 things. Okay, the declaration mentions 3 things: the name, return type, and parameters. Okay, but now for the function definition, it includes now all the statements that belongs to that particular function. Okay, and usually have two types of function. We have inbuilt functions, built-in functions, and we also have user-defined functions. Inbuilt functions are those functions that are already created for you. Okay, so for example, if you want to calculate the logarithm or the square root of a number, you don't need to create the function for square root. You just need to call it from the library. It's already created for you. But now, for the other functions that you want, for example, I want to calculate the volume of a cylinder, that one I'll have to create it myself. And in that case, that's why we are calling it a user-defined function. Okay? In some cases, a function can be known as a method. You'll be able to encounter that maybe when you look at languages such as Java. Okay? So now, how do we define a function? Okay, but before even defining a function, I'm going to show you. Yeah, I can show you how you define a function. And I'm going to share my screen so that you can be able to see. And be able to see as I do it practically. Because the best way to run programming is by writing programs. So I'm still going to work with the same program that I had created earlier. Just a second as my screen has loaded now. I'm going to magnify this so that you can be able to see. So this is a program I created earlier. First, I'm going to delete this program. I'm going to delete these statements so that we'll only have the main function. Okay. So at this point, this is how my main function looks like. Let me return 0. This is how my main function looks like. It doesn't have anything. I have one function. So the first thing I'm going to start with is function declaration. And for user-defined function, the declaration is supposed to be done right after the preprocessor commands before the main function. So that means I will put my function declaration here. I'm what we call a function prototype. The first thing I'm going to start with is the return type. Okay. Then the name of the function. Then inside here, I'm going to have something we call parameters. Int width and int area. So now I have declared my function. The first part here is the return type. Okay, and what do we mean by return type? Since I've said that functions interact with each other by calling each other, for example, if I called Joseph and told Joseph, now you are my function. Okay, I want you to calculate for me the area of a rectangle. Okay, I want you to calculate for me the area of the rectangle. Okay, so there is something that Joseph will need for him to be able to do that. What will he need? For him to calculate the area of the rectangle, he needs the width and he needs the length. Okay, so anytime I'm calling Joseph to calculate for me the area of a rectangle, I must provide him with the width, the values of the width and the length. So that means these are the values that the function accepts. So now after Joseph has calculated, he'll have to return for me something. What will he return to me? The area. Okay, so in this case, what we specify here is the value of is the data type of the value that will be returned. If I type void, it means that function will not return anything. But in this case, I think the function should return an integer, because since the volume is just a multiplication, I expect that it will also return an integer. Okay, yeah. So now that's declaration. How about the definition now? So for the definition, you'll have it like this. The same way you declared it on top there, below the main function, we'll include the declaration, just exactly as it is on top there, int L. Then now you'll have the function body enclosed in curly braces. Okay, and in this case, I'll have int A. Then I'll have A is equal to W times L. Then now I'll return that area that I've calculated, and I'll use the return statement, return A. I'll use return A. Okay, so this means to calculate the area, I'm using the values that the user provided here when they were calling me. Okay, and these ones are nothing but variable declarations. Okay, the only difference with the normal variable declaration here is every variable must be accompanied by its data type, like we have here. So in this case, you cannot have it like this. You cannot have it like int w, comma l. No, every variable must be accompanied by its data type. So now these two, we are calling them the parameters. Okay, yeah. So these two variables are the ones that will receive the values that will be passed by the caller or by the calling function. Then A is what will return to the calling function. Okay. Now, how do we call a function? To call a function, we simply mention its name anywhere in our program. Okay. So for example, let's say I wanted to call this function inside the main. Okay. So I can have here int R. Then I'll say now R is equals to area. Area is my function. Then I'll pass two values. Since from the definition of the function, this function accepts exactly two values of type integer. Then I'll pass 20 and 30. So now at this point, since I've mentioned the name of the function and passed some values, then I have called it. Okay, so now these two values, we usually call them arguments. These ones, we call them parameters. Okay, so arguments are what you pass when you are calling the functions. Parameters are the variables that will receive the values that have been passed when being called. So now, what will this variable contain? It will contain the value returned by area, and in this case the value will be A. So we can even output that. F %d yeah. Hope we are together. So now if I was to run this program, this is what will happen. It will calculate, my function here will calculate the area and return it, which will be saved in my R function. Then here I'll output the area. So that means I expect the output to be 600. So we can try to go, click on execute, and then compile and run. Okay, and you'll see it will print out that the area is 600. Okay, and I think they have learned how functions work. Okay, so before the main function, you include only the prototype, or what we call the declaration. So you mention the return type, the name of the function, the parameters. Okay. Then in the definition now is where you include the function body, just below the main function. Then you can call this function as many times as you want. Are we together there? Anyone with a question on functions? So I can have as many functions as possible. For example, I can have volume, I can have a float, volume. Then I can have int L, int W, and int height. Since to calculate a volume, you need 3 values. Maybe I think this one will also return int. So the return time should be int here. Okay. Then below here, I can define my function. Int volume, int, remember it must be exactly as it is here, int LW.h. Then I left the function body enclosed in curly braces. Then I can have int vol. Then I have a volume, or vol is equals to L times W times H. Then I have return vol. Okay, so that means in my program now, I already have 3 functions. I have the main function and I have 2 other functions, area and volume. Okay, now I can call my function here. And call the volume function here and say P is equals to volume 20, 10, and 30. Then I can output that printf. Yeah. So now I've called the volume function here, and I've passed 3 arguments. So if now I was to compile and run this program, we'll see it will tell us the area is 600 and the volume is 6,000. So that's how functions work. I think at that point, I want someone maybe to ask a question whether they don't understand. Anyone with a question? Anyone with a question? Kevin, Joseph, Weston, have you understood how functions work? Kevin, you have understood?
Yeah.
So can I ask you a question?
Yes, you can.
Can I ask a question first?
Sorry?
Can I ask a question? Can I ask a question?
Yeah, ask.
On parameters.
Yes.
On parameters, do we have the actual parameter, or is it only just a parameter?
Okay, so we'll be looking at later at the different types of parameters.
All right. So,
Yeah.
so the one you have done here, is it an actual?
Yeah, the ones we have used, we have used here we have what we call we have two types of parameters, Kevin. We have formal parameters and we have the actual parameters. Okay, so the formal parameters are the ones which are in the declaration. Okay, so these are formal parameters. The actual parameters are the one you pass here when you are calling the function. Okay, the ones that
So
you are passing. Yes.
So in other words, the arguments are formal parameters, are actual parameters.
Exactly. The arguments now are the actual parameters. Actually, that's the question I was to ask you, and it seems you have already answered it. Yeah. But I can see at least you have got the point.
Yeah.
Yeah, okay. So now, something else you also need to note is about the return type. Okay. So if I specify a return type here, like int or float, that function must have the return keyword. Okay. So for example, here you can see here the return type is int. So I must have the return keyword here to return a value. So if the function is not returning anything, which return type do you think I will use here if I don't want the function to return anything?
You can use void.
Exactly. Yeah. So if my function is not returning anything, I'll use void, because void means nothing. Yeah, and I think with that, we can call it a day. Okay. So I'll give you some time to work on the assignment I have posted. And then we'll meet again next week on Wednesday at 2. Is that okay?
Yeah.
Yeah. So I wish you all a nice afternoon.
Same to you.
And nice weekend too.